Hello students, in today's video we'll be discussing on the topic factors of a quadratic expression and formation of quadratic equation. So, factors of quadratic expression and formation of quadratic equation. Let's take a theorem. So the theorem we have he said if alpha and beta are the roots of the quadratic equation ax squared plus bx plus c equal to 0, then alpha minus beta, x minus alpha and x minus beta are factors. Are what? They are called factors. They are called factors of the quadratic expression. Okay, now let's prove it. Now to prove this, we have to recall certain things that if we are to recall from what we learned in the previous video, that the sum of the roots alpha plus beta is equal to minus b over a. Let me meet equation 1, and then the product of the roots alpha beta is equal to c over a, and let's name this equation 2. Now let me erase the board and the theorem so we can have more space for solution, for proofs. Now, having this, next is that from equation 1, from 1 now, that is from equation 1, we notice something. That if we are to solve, in order to get b, we distribute a so that it will be a into alpha plus beta, which is equal to minus b. Thus, if we are looking for b, we multiply both sides by negative 1, so that, or by negative, so that we can have b to be equal to negative a into alpha plus beta. So we have generated b, or simply say we have made b subject formula from this equation 1. Now from equation 2 we want to make c the subject formula. So now let's make c the subject formula from equation 2. So from 2 we can distribute a to this side, so we can have a into alpha beta is equal to c. Thus, c is equal to a into alpha beta. So you see, and from here we have two very nice equations, of which putting the value of b and c in the quadratic expression. Now, remember, in the quadratic expression, we want to now put the value of this b and the c. Now this is a quadratic expression. Ax squared plus bx plus c equal to 0. So now we have that ax squared, our b now is minus, is negative. So we have b to be negative a into alpha plus beta x, then plus c. Our c now is alpha, that is a into alpha what? Beta, which is a quadratic expression that we are substituting it into. Thus, if we have this, we can, at this point, we can, since a is common to all of them, we can proceed by factoring a. So we now have this to be equal to a into a bracket of x squared Okay, if A is out of this one, we have negative alpha plus beta. Then if A is out here, we have only alpha beta, right? So this is what we have. Next, inside this bracket, we now factor what is inside the bracket. Now if we factor what is inside this bracket, we are going to obtain 2 bracket of x minus beta. This is going to be minus alpha. So that when we expand the bracket, we can obtain back this. So next, looking at this, we have that, and so looking at this, we now see that this is that it implies that ax squared plus bx plus c is equal to this a into x minus alpha, x minus beta. Remember, this is the proof that we are proving. So now, we can also rewrite this so that it can be of the form that is dividing through by a. We have x squared plus b over ax plus c over a, which is equal to, in fact, is equal to x minus alpha, x minus beta. So now, how is it equal to? Because we know that this value here is simply b over a. If we take it to the other way around, it's going to be negative into alpha plus beta. Is some root. Okay, so that is what it implies. And then this one here, what it implies, c over a is simply alpha what? Beta. Did you see that? It relates back to what we have initially, and thus this is a proof. So this is what we can now use to find factors of the theorem 1.1. The theorem we just stated earlier, so we can find the theorem of that quadratic equation if alpha and beta are known. Do you understand? So if alpha and beta are known, we use it to find the roots of that theorem. Now this is what we have. Now let's look at that a little bit. Provided that alpha and beta are known. So now we have that if this x now, as we had initially, if x is equal to alpha and x is equal to beta. Now what we do here, if we say that they are the root of the quadratic equation ax squared plus bx plus c equals 0, then this is what happens now. Since these two are roots, now bring alpha to come and meet over the equality sign to meet x. So we have x minus alpha equal to 0 and next x minus beta equal to 0. So having this now, you notice that this now becomes x minus alpha in bracket x minus beta all equal to 0. Thus, expanding these two expressions, we are going to obtain, expanding the expressions, x times x is x squared, then x times b is minus b beta x, x times alpha is minus alpha x, then this is alpha, negative alpha multiplied by negative beta is positive alpha beta. Okay, so that is also equal to 0. So let's look at this again. Factor out x, we have this to be alpha plus beta x, then plus alpha beta equal to 0. Did you see this? So this here is the sum root and this is the product root, which is exactly what we have over there. And we said that this is simply equal to, because over there we have it to be what? We had this to equal to, that means we said that, remember I expanded this, I showed us what this is in the expansion. I expanded this. I told us that this is what we have there to be beta over a, right? If you revise this video, you're going to see that. And I told us this one is just that place of c over a. Thus, this is equal, or let's say equivalent to x squared plus beta over ax plus c over a, which is what we have already by comparing the coefficients. So we have that. If we compare the coefficients here, we have that what? Alpha plus beta is not going to be what? So if we check it, comparing the coefficients, alpha plus beta will now equal to minus b over a, and alpha beta equal to c over a. And that is what satisfies the proof of the theorem. Thanks for watching this video. In the next video, we are going to be taking an example on this problem. This is Sir Jude on Extreme Learning website. Thanks for watching this video.